and it should quiet down, right?
I moved to the U.S. in 2000. Just want to make sure it goes in
Ready?
My wife is
All right.
we met online, and then we did the long distance thing for a while, and then we decided, okay, one of us should move. It probably makes more sense for us
Yeah.
to move here.
Yep. All right, we're ready to get started, finally. So everybody, welcome to the library and performance tuning for Linux. We were going to do this earlier in the year, so I actually formatted all the slides for online, so the text is going to be really small on some of the slides, but usually online you can still read it. I'm glad the library upgraded their projector, because as I was driving here, I was like, oh man, nobody's going to be able to read the text on the slides. But it looks like it's going to be okay. We got Peter recording this, and I'm presenting, so here we go. All right, so performance tuning for Linux. It's complicated. There's a lot to it. You can tune kind of any part of Linux, and that's what this graph really shows. So you can see that there's stuff for tuning applications, system library, system calls, the network stack, the scheduler, the virtual memory, device drivers, the I/O bridge. You can tune pretty much any part of the operating system. And we could spend days and days and days talking about performance tuning. So today, instead of doing that, since we only have about an hour and a half and we have 150 slides to get through, we're just going to focus on a few things. We're going to talk about monitoring system resources so you can tell if you have a bottleneck somewhere. We're going to talk about how to collect data. And then we're going to talk about an easy way to tune your system, just to give it different operating profiles with a system called TuneD or tuned. So without further ado, let's start with monitoring processes. And this is kind of like one of those follow along on your own computer type of presentation. So if you have a computer in front of you, feel free to run these commands. The first one we're going to talk about is the PS command. This thing, all it does is it lists the processes that are currently running on a system. And there's a couple of columns here that you want to pay attention to. The first one is the second column, and that one's labeled PID, process ID. So that will tell you the ID of any process. The second column that I have pointed out here is the terminal that the program was launched from. If you see a question mark, that means that no terminal was used to launch a program, it just launched. But if a terminal was used, that usually indicates that a user has started a process. And then, of course, the first column tells you what user launched the process. Linux is a multi-user system, so you can have various users launching different processes throughout the time. So you can see here on this example from my laptop, between myself and root, we've launched a couple of processes there around Gnome and GDM sessions, stuff like that. All right, let's dive into PS a little bit more. You can extend PS and what it shows by using switches, just like any other command on a Linux system and most other operating systems. Well, some of the ones that are more interesting are PS-EF, and that lists every process that's running and just puts in standard output format. And then PS can also be used to look at other options that you have with running processes. Hold on a second, I'm going to let somebody else in.
I guess when I was first introduced to like Unix and Linux,
Mm-hmm.
just getting my head around that. Oh, everything's a file.
Everything.
And
Yep.
you could just like cat files and see what's going on.
Mm-hmm. Yep, and when you run these commands, you know, with the switches on them, some of the extra columns that you show up, CPU percent, shows the CPU usage during all previous, during the previous second as the sum across all CPUs, the amount of memory, the memory ratio that's being used, resident set size, and time. Time is important to watch because that'll show you how much CPU is time. Now, during this presentation, we're going to use a couple different terms around CPU usage. We're going to talk about CPU usage, and we're also going to talk about CPU load. Does anybody know the difference between usage and load? Anybody online? Nope. All right, so usage is how much time your CPU is being used, right? So it's a measure of time. And load is a measure of processes, how many processes your CPU is currently running. So they're two different things. You can have a lot of load on your CPU, a lot of processes waiting for time with the CPU, or maybe they're idle, they're just checking in. So you can have a high load and low utilization. What you don't want is high utilization and low load, because that means that something's hogging your CPU. So moving on. Another process that's really handy, kind of shows you the same type of information as PS, and that's the top command. You can run top, and what it does is it provides a dynamic real-time view of the processes running on your operating system, and it can order them as far as which one is presenting the highest load, which one's using most CPU time, which one's using the most memory, and you can sort the columns. Some of the important columns here are PID, which again is the process ID. You can use Shift-N to sort on that column. You can use Shift-M to sort on memory, so that's the res column, resident memory, and then Shift-T to sort on time, how much time that process is actually spending running on the CPU. Pressing F exposes a menu, and you can select other systems from there. You can see on this command I typed in top space dash N1. What that does is tells top to run one time. So if you don't give it that dash N1, it'll run over and over and over, and it just keeps updating itself every second, which is great sometimes for troubleshooting. Other times you just want kind of a snapshot. You don't want to look at the numbers too often, and you can just do, run it one time, run it 3 times, whatever. And we'll see that with a lot of other commands as well. Another thing to look at when you're talking about performance tuning is memory. How is the memory being utilized in the system? And a good thing to look for when you're looking at your memory utilization is you want your available memory to be at about 20% of the RAM that you have available in your system. So you have a system with 8 megabytes of RAM, you probably want right around 1.5 meg or 1.5 gigabytes of RAM available. If buff cache and available are both near 0 in these columns, then you have a low memory situation. So you want to have the buffer or caches high, and you want to have the available RAM high. Now you can see here I ran the command 3 different times. The command is the word free. And if you just use free, it puts everything out in bytes. Sometimes that's kind of hard to ascertain, like what is that huge number, 128.29408. It's a pretty big number. If you want to do that in megabytes, you just do free-m, or if you want to do it in gigabytes, free-g, and that shows you how much RAM you have, and it's a little bit easier to read then if you use megabytes or gigabytes. And so I just ran the same command 3 different ways here. But good way of gathering information about the memory utilization of your system. Another subsystem in the laptop, we've covered CPUs, we've covered RAM. The other one is storage or disk. So there's a couple different programs that you can use to look at your disk utilization. The first one is DF, which is a way of displaying free disk space, so disk free is how I like to remember it. And if you do a -H, that puts it in human readable format, a little bit easier to understand again, because the numbers are something that we can calculate more easily as humans. But as you can see here, the different file systems show how large they are. If you look third from the bottom, that's my Fedora localhost live home directory, my home directory. So it's 812 gigabytes. I'm using 100 gigabytes for it. And that means I have 671 gigabytes free. It's about 13% used. A lot of times, if a Linux file system gets filled, especially var, you will start having problems. So a lot of times, security practitioners, they suggest that you have like var on a separate partition, var log on a separate partition. And that way, if an individual partition fills up, it's less likely to bring down the whole system. You may just not be able to capture any log information if var log fills up, but the system will continue to run. So different strategies there, and looking at the disk free and seeing how much disk space you have, making sure that a full disk is not shutting down your system.
I found also /temp builds up. That can also
Yep.
cause issues as well.
Yep, /temp can kill you too. All right, next one is DU or disk used. This gives you a summary of disk usage. It's a set of files recursive. It can scan recursively into your directories and tell you how much space each directory is taking up. So if you're one of these people who use the downloads file to, or downloads the directory in your home directory, anything you grab from the internet, you just throw it in there and lose track of it and it doesn't get pulled out. You kind of use it as temp storage because it's called downloads. This is a good way of like, oh my gosh, I'm running out of disk space. Let's see what is using up all that disk space. You can go in here and you can actually see what the size of every file. You can sort it by file size. You can do all kinds of cool stuff there. And that'll help you to see what is taking up the space on your hard drive and what files you should eliminate to quickly recoup space on your file system. If you do -s, it summarizes everything. So in the example on the screen, du-hs home TED, it tells me I'm using 100 gigabytes in my home directory. And that's because I have a lot of ISO files. So, and it was summarized. If I didn't have the summarize function on there, the S part of -hs, it would list all the files and the size of each file in my home directory. So, cool command. All right, now we're going to get into a different set of tools. So, you know, the first ones they seem to be related to the major subsystems or just direct commands to look at data. The next bunch we're going to look at are utilities that fall into either SysStat or VMstat utilities. And a lot of people, when they hear VM, the first thing that comes to mind is virtual machine. We are talking virtual memory today. So when you hear me say VM today, think virtual memory instead of virtual machine. So 4 utilities, and the first 4 utilities are installed in Fedora and Red Hat Enterprise Linux systems as part of the SysStats package. And then this last command, VMstat, that's installed as its own package. But the first 4 we're going to talk about is Iostat, which reports CPU statistics like I/O for devices, partitions, network file system, things like that. MPstat reports individual or combined CPU-related statistics, and we're going to have examples of all these too. Pidstat reports statistics for Linux processes, including disk, I/O, CPU, and memory utilization. So we're just going to expand on those commands that we've already explored. And then SAR. SAR is really cool. We'll spend a little bit of time in SAR, but SAR collects, reports, and saves system information. So you can go back and look at how your system is performing over time and determine, okay, you know what, it looks like my memory utilization spikes up at 2 a.m. What else is going on in my system at 2 a.m.? Right? There's something that's causing my system to use a lot of memory, and it'll help you troubleshoot your system that way. And then VMstat reports information about processes, memory paging, block I/O, traps, disks, CPU activity, anything that has to do with virtual memory stack. This is exciting, isn't it? So, performance tuning, it's not, to me, it's just not hugely exciting. But we'll get through this. It's kind of like me doing gaming for Linux. I'm not a gamer, but yeah. Okay, so it's exciting for you guys.
I would venture as far as you will get into situations very quickly become surface. This stuff is how you save the data.
Yeah.
And it's important to realize what's running under the hood.
Yeah.
It's like, you get Linux is running, but
Finding out where the bottleneck is when things are not performing or vice versa.
Yeah.
Very, very important.
And I was joking, we don't have 150 sites, we only have like 60. So, yeah, it's not that bad. All right, so Iostat, disk I/O utilization, Iostat. The Iostat command is used for monitoring system input, output, and device loading by observing the time the devices are active in relation to the average transfer rates. The Iostat command generates reports that can be used to change system configuration to better do things. So, different options when you run Iostat, and you can see the example on the screen there where I run Iostat DYZ. D is disk report, Y is ignore the first report after booting, and then Z emits idle devices. And what I'm able to do there is, with the devices on my system, all the DM devices, my NVMe device, and ZRAM, which, yeah, there's another name for that. it'll give me an idea of how things are working. And this does not take a whole lot of time to gather. If you want, we can actually come over to our command prompt, type in Iostat DYZ, and I don't have it installed in this, so we'll get it installed really quick. And
So much easier to see small text on this.
isn't that great?
They want us to make it a little bit clearer.
Yeah, there we go. Okay, so running Iostat DYZ, it comes up and it shows me my devices. Since I made the slide deck, I reinstalled my system, so some of the devices may not look the same. But trust me, they're all there. Okay, so it's showing TPS transactions per second, kilobyte reads per second, kilobyte writes per second, kilobyte, I forgot what DCDR is, kilobytes read, written, and that's cool. All right, the next one, CPU utilization, MPstat. Key columns in the output, MPstat just, it's a command that writes the standard output. Activities for each available processor or CPU core. So the first one is, of course, is 0 because that's where Linux always starts its numbering. Global average activities among all processors are also reported. Key columns, the CPU, it'll show you the CPU number. It also starts with the word all, so you can see what the average is across all of the CPUs. And then you can see how much percent of the CPU is for user space processes, how much of the CPU is being used for system processes, and how much of the CPU time is idle. So if we come up here and we type in mptstat, or maybe it's mpstat dash all, I didn't like that. Okay, so it shows me all of the CPUs in my system. I do have 16 CPUs in my, well, it's an 8-core hyper-threaded processor on my laptop, but shows up as 16 CPUs. As you can see, doing this presentation, it's mostly idle. So I probably don't have much of a bottleneck right now, just running this presentation and running the Google Meet software, but things are running pretty nice. The user load, which would be my browser window that's open, the terminal windows that are open, is fairly low. I think the highest one I see there is 8%, 9.25, 9.31. So a little bit of a low, but not bad. And you can see some other stats on there too. Nice and low. The system isn't taking up much time. There's not a lot of I/O processes in a waiting state for CPU time. So everything is running pretty decently on the system. So nothing really to worry about there.
What would be indication of a bottleneck? Like you might have like load is slow.
Yeah,
Things
low
are running slow because they're like block waiting on things.
I/O wait usually. If the I/O wait is really high, that means you have a lot of processes waiting to talk to the CPU or waiting to talk to some other system
Also,
in your system.
sys is very, very high.
Yep.
For instance, you may be swapping a lot. You should not.
Mhm.
So you should see the load on the user. And if you are a lot of stuff going, you may see some nice. But if the user is not what's taking all the time, the majority of the time,
Yeah, so I haven't used MStat, so I mean some of these columns I recognize like user and sys and IO wait, but some of these are not so familiar. Like
Yep.
steal, guess. Could you explain what you think the columns look like?
You know, let's bring up the man page then, MPstat, and we'll look for
I know you're kind of
steal.
so
No, it's really good because I get to show how man pages always have the answer. And, you know, just like if you take a certification course, you don't have to know everything. You just have to know that the man pages always have the answer. All right. I love man pages. So steal, these are all the columns right here, okay, and what each column does. So steal, since you asked about that one, shows a percentage of time spent in involuntary wait by the virtual CPU or CPUs while the hypervisor was servicing another virtual processor. So how much time was spent waiting? Guess shows the percentage of time spent by CPU or CPUs to run a virtual processor. So both of those kind of have to deal with running virtual machines, not virtual memory, but virtual machines this time. And then gnice shows the percentage time spent by CPUs running a nice guest or a virtual machine. IRQ is exactly that. To service hardware interrupts.
The way I would get it, if everything except the user is high, then you need to dive in to figure out
Yep.
what the system is doing. And there is most likely a configuration problem somewhere if that's
Yeah.
the case.
But if
This explains why you might have an issue or where you may have an issue.
Yep. But if I'm a system administrator and I bring this up, somebody complains, hey, the system is slow, right? We get that all the time. And I bring this up and I see that something in the user column is really high. I know that there's a user around my system who's doing something inappropriate, or maybe a process has gotten hung that they're running, right? And so I can go looking for,
Something that's just
yeah.
CPU intensive.
And if I can troubleshoot that down, I may,
But what you can see is it's not a system configuration issue, it's probably whatever software it is you're running.
yep.
I mean, there could be a process running that's encrypting stuff that's on disk, so that's,
Mhm.
you know.
That would probably be a system process.
Something high in
Yep.
user might be, it's just an expensive process. It
Yeah,
doesn't need
I'm running a spreadsheet in like LibreOffice Calc, a spreadsheet that's just churning away on like 2,000 columns and 5,000 rows of data, right? That may cause a spike in user process, but as far as like encrypting disk, that's probably going to be a system process, so you'd see the spike in the system column. So, but it gives you an idea.
You have 16 cores. What if you're looking at this and one of them is saying 100%, everything else is saying 5?
Then you have something that's expensive running in a single thread, and you need to figure out how to make it multi-threaded.
Yep.
Those are sort of things I look at too, because
Yep.
I want to utilize that
Yep.
scores.
And that's the kind of data you're getting back here from all that information, is to sort of figure out where is my bottleneck, what's causing it. And it may not be a system problem, it may just be the program.
Yep. And so doing this part, it might not, we're going through a lot of commands really fast and like, hey, here's what this command outputs, here's what that command outputs. But the first real thing you have to do with any kind of system tuning is to figure out how your system's currently running, right? You can't tune a system that you don't know how it's running.
So, let's say, like on just a base install of like the
Mhm.
CentOS or Fedora or something, what tends to be, at least in your experience, what tends to be the biggest hog of resources if you just kind of leave it and don't
As a server or as a workstation?
either one?
Very different answer.
Yeah.
Let's say workstation.
Workstation, yeah, graphics, either X or Wayland. Yeah, X or Wayland's usually the big hog.
Firefox and or your Chrome, and you look at it, and it's eating half your system resources,
Mhm.
not more, right?
And that's on a base install for like Chrome
Yep.
and stuff?
Yeah.
Yep.
So right now, these numbers that you see in the user column, they're higher than the system column, obviously, right? The only thing I have running right now is 2 Chrome windows, a terminal. That's it. And the desktop. So Gnome can be a resource hog at times. If you open up if I open up a web browser and I start running, and I stay on Facebook for a long time, the Chrome browser will really slow down because of Facebook, right? So I should probably try that with Firefox, but yeah, this is a good way of looking at the different CPUs and seeing what's going on each CPU though. And beginning that troubleshooting process of, okay, I see that my system is using a lot of these resources. How do I make it use the memory better? How do I make it use the CPU better? So the first step of performance tuning.
That's why a lot of people use Firefox, is Firefox is a lot more scalable
Yep.
in terms of what you want to turn off or turn on. Make it a lot more for you.
Yep, so let's grab,
Although with my work, we're kind of standardized on Chrome because we have so many, Chrome-based applications, protocol applications. So, but at least it's not Internet Explorer.
It's not, yeah, it's not Internet Explorer or whatever they're doing, it's Edge, yeah, exactly.
okay.
Thanks, I don't want to care what you call it, it's Internet Explorer.
And on a home computer at home, I have like this.
So the next command we're going to look at, and I already ran the command while you guys were talking, is pidstat. Pidstat is used for monitoring individual processes and seeing how those processes or tasks are currently being managed by a Linux kernel. It writes the standard output, all the activities selected by the option -P, so you can either grab all of the PIDs without doing a -P, or you can grab a certain PID. So while you guys were talking, what I did was I ran a PS command, looked for my Chrome process, got the PID of my Chrome process, and then ran this pidstat -P, PID of my Chrome process, and then the numbers 1 and 3. All that 1 and 3 say is it should do a retrieval interval of 1 second 3 times. And it's going to look for that individual PID. So again, we can scroll information on our screen until the day is over, or we can just limit how much we see and how our process is doing. So with that, I'm going to run the command again. And we'll see that comes through and it says, okay, UID is 1000. That's my user ID. The PID is 7811. That's my Chrome PID. You can see the command over on the right-hand side, right-hand column. It also tells me what CPU that thing is running on. So Chrome is running exclusively on CPU number 10. Let's see if I can find out where that's not going to work. I'm going to see if I can find out where, no.
Looks like Ted is all over the place.
Yeah, he gets around.
So one thing I noticed, and you just did it too. So like when people use grep, 99.9% of the time they're just looking for a fixed string. And yet, if that's what you're doing, there's a faster grep.
Yeah.
You can say fgrep, or you can use grep with the, I think it's capital F is the switch, and it does just a simple grep, where you're just looking for fixed strings, and it can be an order of magnitude faster. I found, like when you're like searching through a lot of stuff. So I just always just type fgrep by.
If you have gigabytes or terabytes of data, then stuff like that is important. For commands like this, computer sizes today, you saw, you read the displacement at the time you got.
Yep.
You just also, you're not seeing.
So
Well, I'm running commands where I've actually noticed a difference in the performance of the fgrep versus the grep.
If you have a lot of data in your life, then it makes sense.
all right, so what I did this time, because Gnome wasn't really showing us anything, my everything's kind of either running in the background, it doesn't have focus right now, or is, not running in the foreground. So Chrome was giving us a bunch of zeros, not too exciting. Instead, what I did was I found the PID number now for my Gnome terminal, which is open and we're using it. And you can see that the Gnome terminal is actually bouncing around a lot between CPUs. 1 second it's running on CPU 4, and then it's running on CPU 12, then over to CPU 6. And also, the user time changes a little bit. So when the command first started, it got that second stat there, and it says that the user time is 1, right? So we can actually see that, yes, it is collecting some good stats there. As the command ends, it gives me user time of 0 again, averaging out to 33% for, or .33, a third of a percent for its entire run. So kind of a cool thing. Again, if you know the PID of something, you think it's misbehaving, you can look at it. Maybe it's like Chrome, where it's attached to a single CPU core, or it's something that's actually multi-threaded. You're going around and hitting different CPUs. It's being scheduled decently, but allows us some insight into what's going on our system so we can start troubleshooting any issues that we see. All right, next command, VMstat, virtual memory stat. VMstat reports information about processes, memory, paging, block I/O, traps, disk, and CPU activity. By default, it displays information in kibibytes, KI bytes. And kibibytes are 1,000. So there's two different ways of measuring. There's two different ways of measuring memory. Some people will say a megabyte of memory is 1,000 bytes. Some people say a megabyte of memory is 1,024 bytes. 1,024 is actually the right answer, but we're not going to get in an argument about that. So the 1024 measurement is called a kibibyte, and the other one is called a kilobyte because it sticks with the regular metric way of saying 1,000 of this or 1,000,000 of that. Okay, so kibibytes, 1024. Okay, that's all we're going to say about the kibibytes versus kilobytes versus maybe bytes and megabytes and gigabytes and yeah.
So the one with the I is base 2, right?
What?
The one with the I is to a power of 2.
Yeah.
The one without the I is to power of 10, right?
Correct. You got it. All right. So you can just, when it displays information, it defaults to kibibytes. However, you can tell it to display in megabytes, kilobytes, or mebibytes. Okay. So the small k, the by default is kibibytes. If you want to do kilobytes, small k. If you want to do megabytes, small m. If you want to do mebibytes or whatever they call it, capital M. All right, depending on what you want to see, you can say however you want. But VMstat, and this one is another one of those that we'll probably have to go into the man page. You can see it actually has columns and subcolumns. So over here on the CPU side, since that's what we've been talking about, you have US, SYID, WA, and ST. That is user, system, idle, wait, and so on, like we have been looking at. For the IO column, you have BI and BO. That's bytes in, bytes out. System, I forgot what those two columns mean. Swap is swap in, swap out. If you see a lot of swappiness on your system, that usually means that you are running out of memory. And so it's beginning to use your hard drive to cache things in and out of memory. So seeing a bunch of zeros in the swap columns is a good thing. And then you have memory, swap pages, memory, free memory, buffers, and cache. As long as those are, the cache, if it's too high, that would be a bad indicator too. And again, free memory should be at least 20% of what your total system memory is. Okay? So, anybody want to see that command run in real time? All right. And VMstat. And I always forget the command. So, and we're going to do that 1.3 again, so it'll run it 3 times with an interval of 1 second. Okay, so we run that, and we see our output there. Free memory is looking good. It's actually, it decreased a little bit there during the second run, but that's understandable. It was running an extra process. And then we see that swap is really looking good still. It wrote a little bit. There was a little bit of I.O. there with some bytes being written in and out. CPU is still mostly idle, 91 or 87%, so we're looking good. And that's how you quickly look at one of those outputs and just, again, seeing how the entire system is doing. VMstat looks at the full spectrum of all the resources on the machine. Look good? All right. And here's what all of those columns mean. So I forgot what system IN and CS were. Interrupts and context switches per second. So, and we'll make sure that everybody has a copy of this presentation for later on. All right, so now we're going to get into system reports, or SARs, activity reports. So again, performance tuning is a complex thing. There's a lot of different things that you can tune. What SAR enables us to do is actually generate activity reports from all the systems that we have in our computer, whether it be the application stack, the scheduler, the TCP/IP stack, I/O, you name it. We can do something with that. You see up here in the upper right, even under hardware, we have fan. If you want to monitor and get a system report on your fan speed, yes, you can do that. Okay. A lot of people, especially like my son, he's always worried that his CPU fan wasn't spinning fast enough. So yeah, if he wasn't running Windows, he could actually look and get system reports on his CPU fan. All right. So SAR reports. The SAR command writes to standard output the contents of selected cumulative activity counters in the operating system. Some of the most common command options is -B, report on memory page statistics, lowercase b, reports on I/O, lowercase d, reports on disk I/O for block devices, -F is read from a log file, network stats, queue length, and then reports on memory utilization. So when we run one of these commands, it's going to output some different columns for us that we haven't seen already. So we'll see columns such as TPS, RTPS, WTPS, DTPS, bread per second, BW, which is actually BRead, not bread, BWRTN per second, and BDSCD. Down at the bottom of the page, I spelled out what all of those things mean, with the exception of the last one, and I don't know why I missed the last one. But TPS is transactions per second. That includes reads, writes. RTPS is read transactions per second, and then the BRead and BWRTN is bytes read and bytes written per second. Okay, so that is SAR. SAR is fun, but to get into other ways that you can monitor, well, we'll run a SAR command really quick. SAR-O report. Okay, so here's what a SAR report looks like. And that is the first one. So I did a -O, which is going to give me CPU stats. If I did a -B, that should give me I/O, which will look a little bit different. Or not. Oh, it's not going to let me output. And so here's my I/O report. And this is similar to what we see on the screen. The first command actually allowed me to write something out, I believe. So I should have a report.sar. So right down there in the red. But the second command doesn't report anything out. So you can use those. You can run that while you go and get lunch or something if you think you're having a problem at work. Getting lunch probably isn't the right thing to do if you have a problem at work. But if you wanted to, you could run the SAR command, collect information over a period of time, put it in a SAR report, analyze it later. Another way that people like to go and get information from their system, I'm going to exit the presentation for a second, is through the Gnome system monitor. And so believe it or not, this is actually pretty useful because it shows us all the CPU activity and just puts on a nice graph. So if we suspect that something might be going on with our computer, we can run this, put it up on the big screen up on the wall or something at work, and we can just glance at it every once in a while and be like, oh, there it is, it's spiking up. And then we go and run our reports really quick to see what is going on our system. That might be a little bit better than sitting there staring at things for a long period of time. That top graph of mine looks like a complete mess, and that's because of all the CPUs. I think there's a way of turning those on and off. But you can also, with the system monitoring tool in Gnome, you can look at file system usage, and you can look at processes that are running on your system. So it kind of combines up a lot of those commands that were already running on the command line into a nice little GUI interface that we can click around in or throw up on the wall in our data center and just watch as throughout the day and make sure that things are staying nice and steady throughout the work period.
Can you specify where the SAR report's written to?
Yeah. Yep. I just said same folder, my home folder. I can go through and erase that later. But yeah, you can save it on a network drive or a different folder, whatever you want to. All right. Another way that people like to do system reporting, this one's getting more and more popular, is through, what? Yeah, yeah. I really like the cockpit web interface. All right, so if you go on usage and then you click view usage history, what's really cool is with the cockpit interface, we draw these crazy graphs, right? And we talked about load and CPU usage earlier. here's a way that we can look at usage, and we look at load on the other side. So we can see where we have high load but low usage, relatively low usage depending on load. We should be okay. What we didn't want to see is that we have a high load and high usage. So since the usage is low and the load is high, we should be okay. At different areas, you can see that it detects a spike. So like right here, disk IO, I have a green spike here. I can go in and use this drop down, and I can actually look at some log information coming from the kernel that might indicate why that spike happened. So this part of the cockpit interface can be especially useful for gathering stats about your system or troubleshooting your system, looking at how it's performing, because we have graphical representation.
Meetup is going to stop. You said they only have an hour. I've never seen that before. I do have it on YouTube, and I did put the link in the chat where it's being broadcast.
What?
Yeah, I've never seen that before.
Okay. Hold on, people. I'm going to get a new URL. I'm going to paste it in chat really quick, and then we will be able to continue.
Start up another instant meeting and have everyone log onto that. So
Well, I can always go out and use, is this your work computer? Or do you have access to?
No.
this is how I've been meeting my coworkers for the last year and a half.
Well, I had a problem because I had a free Zoom account. It's like, oh, we're only gonna give you 45 minutes.
All right, so if you're watching us online, this is the new meeting ID. Just everybody click on that link, and you'll go to the new meeting ID. That should last us for the second hour. And I apologize for the hassle. First time we're doing it this way. All right, I'll close that one. And,
So what were you using prior to Google Meet?
Blue Jeans, right?
yeah, we've used Blue Jeans in the past, and
So
I didn't see when I signed up for this meeting, I didn't see that there was any restriction on time.
So I've
So-
done Google Meets on other groups, and we've even used it in some of FredLugs for more than an
Mhm.
hour. This must be a reason for it. Never seen
Yeah,
that.
I've never had that issue too, but I'm probably using like a corporate version of Google Meets.
Yeah.
So I have a weekly call that typically lasts for at least an hour and a half, if not 2 hours. I have never seen this issue.
All right. Are you back in there, Peter, so you can let people in?
Well, so I don't depend on the
Oh.
meetup to do the broadcast, but I am in here.
Okay.
Everyone-
Yeah, if you can let
and I'm
people in.
checking the chat, so
Okay. All right, so back to cockpit. Let's find. Okay, well, I closed our cockpit window. Anyways, under the covers, what Cockpit was using to collect those stats is called Performance Copilot. Performance Copilot is its own tool as well, and has 3 parts. Performance Copilot, or PCP, that's the open source release that provides unified abstraction layer for all the interesting performance data in the system. Fun. PCP GUI is a visualization of the Performance Copilot toolkit.
well, you're not sharing the desktop online.
Oh.
So you want to share on the meeting.
Okay, sorry. Let me fix that really quick.
Pick your screen, pick your question.
All right.
There we go.
Everybody should be able to see that now? All right, and then the third part of Performance Copilot is the PCP system tools, and that contains additional system monitoring tools written in the Python language. If you want to enable metric gathering, you have to enable the PCMD service. And that's just a performance metrics collector daemon. That is what the cockpit web interface is using to collect all the metrics on the system, and then also identify spikes so that you can go in and look at what was going on in the kernel of your system, whatever, of why the spike occurred. However, it is its own tool. It has its own website. It's a great tool. So we're going to run a couple of PCP commands here the first we're going to run is PCP free. And what PCP free does is it gives us an idea of how our memory is looking at. Remember, the free command is how we check memory. PCP free just gives us the same information. So our actual memory, we have six. Yep. If you're online, does somebody have a question online? Okay. All right. Cool. All right, Aslan, we muted you because there was a lot of noise coming through. All right. So PCP free displays memory and swap information. Remember, we want swap to be 0. 0 use swap. We don't like using swap. So this one is running really well. I wonder if I can do a -H here. No. But I can do -K or M. So, or G for gigabytes. Okay, so you can do different things there to show it in a different way. So things would display a little bit differently, a little bit easier to read for the memory part. Okay, so memory in our window looks good. 14 gigabytes memory total, 2 are used, 9 are free. That's above the 20% threshold, so I'm pretty good. No, those numbers don't add up. I don't know why. Okay? Normally if you have 14 total, then 2 plus 11 should equal 14, or 2 plus 9 should equal 14. It doesn't. Don't know why. Then we're using some swap. Next command is going to be VMstat. That's going to show system resource utilization, similar to the VMstat command. The -S option sets the number of samples to collect. So VMstat, there it is, -S. We'll do 5 samples. So it goes through, and this is going to grab some information about the entire performance of the system of what's going on right now. It's very similar to what we did. And obviously, it's taking more than a second between samples, but we can see how the CPU is doing. We can see the system, swap, and I/O system. So I/O is doing a little bit of work. Not too bad, though. And then lastly, we can do PCP dstat. And what PCP dstat should do is show some general system performance data in the same interval. So it's going through and it's gathering a lot of information here. We can see we have system information over on the right, paging, network, we have disk total for in and out, and then we have CPU usage. I wish it would keep the columns in the same order. It doesn't. I don't think there's an option changing that, but we can go through and we can see how the system is performing at any time. What's really interesting about these stats is that you can also put them into a GUI. And when you do that, there are actually 2,400 different points in your system that Performance Copilot can look at. Okay, so that's a lot. Like we saw the really complicated graphs at the beginning of the presentation. 2,400 different points of metric gathering for Performance Copilot. So if you type in this command, the pminfo grep load, or you type pminfo-dt, which just gives a description and a one-liner, you can see when I grep load, there's 7 or 8 different things about just looking at load, kernel load, KVM load, proxy load, hot process control load, so all kinds of cool stuff there. And then if I just look for kernel all load, you can see that kernel all load gathers data over 1, 5, and 15-minute load averages. It shows you a floating point number, and it has some other information about it. Okay, that's the one-liner. If you want to actually see this in action, pmval is the command to run. So we'll do pmval, make sure I get this right. We'll do 3 and kernel dot all dot load. And so we can go through and we can collect the utilization on our kernel 3 samples. So we're collecting dash S. And so it gives us some good information. If I didn't want the 15-minute load info, I can just specify for dash I, give me the 1 minute and 5 minute, and skip everything else. And it'll just show me the 15-minute. You could also just say pmval dash I for interval 1 minute, and show me the load over 1 minute, and run that a number of times. Okay? Other interesting thing about pmval is it can be used with remote host where PMCD is running. You just connect to port 44321, and you can actually collect information off of remote hosts using the dash H option. So make sure that port's open on your firewall, and you can collect stats remotely that way. So, kind of cool. The other neat thing about Performance Copilot is it has a GUI. And if we wanted to look at the GUI, what we'll do is we'll find the kernel stuff that we've been looking at. So, and this to me is a little bit backwards. Because usually you select things, right, on the left-hand side of the screen, and then you hit an arrow and then move to the right-hand side of the screen. This is backwards. You select things on the right-hand side of the screen, and then you we'll select all 3 of these. You move them over to the left-hand side of the screen. Okay, a little backwards. And when you're done, you hit OK, and Performance Copilot will start showing drawing a graph for you of whatever of those 2,400 metric collection points that you want to see. You can select any of them that you want and bring them up on a graph. And that will help you correlate information like, hey, I'm seeing like spikes in both disk I/O and CPU utilization. What's going on? So you can just capture those 2 points, maybe some other points around disk I/O or CPU utilization, and you can try to correlate what is happening on your system when disk I/O goes high and CPU utilization goes high at the same time. So 2,400 different points of collection. And that is the Performance Copilot GUI. All right. Next, displaying hardware information, because sometimes we have faulty hardware. I have actually, back in my network system administrator days, I was ordering a bunch of network cards from 3Com, and this is never supposed to happen, right? 2 cards showed up. We installed them in the computers, put the computers out on the network. They had the same MAC address, right? So traffic never knew where it was supposed to go. It was crazy. It was hard to troubleshoot. So how do you sit there and display that type of information about your computer? Another issue I ran into recently is I have a bunch of these small computers at my house called Udo bolts. Every single one of them has this. So there's some information that Linux uses to gather uniqueness about a system. And it's all stuff that's embedded into the BIOS and different parts of the CPU, different chips. When it queries the Udo bolts, they are all identical, all 4 of them. So when you register, I was trying to register them to the satellite server at my house for system management, and the satellite's like, nope, I only see one of them. And then I'd register the next one, and the one I had registered would go offline, and the new one would come online. And I'm like, what is going on? Why are the other 3 like offline, and the one that I just registered is the only one that sees? Turns out it was the info that gathers for uniqueness was the same across all the different systems. There was no uniqueness to those 4 boards. So that problem actually happens, I guess, more often than people would think, but there's a setting inside satellite where you can set satellite to create its own uniqueness number and override what comes in from different systems. So when a system registers, it makes it a little bit harder to manage house, but it worked.
Were you able to change the MAC address of the card, one of the cards?
No, we just took the card out and ordered another one. Yeah.
So that's not something that an end user can mess with.
It can,
Yeah.
but in that case, let's say there's a high performance card, it gets a call from their side.
So first command to use to look at hardware info is Dmessage. It's what Dmessage does, according to our slides here, is Dmessage used to examine or control the kernel ring buffer. The ring buffer is kind of cool. Once I was asked a question about how does the kernel ring buffer, how's it work in association with virtualization? And basically what the ring buffer does is it allows commands to come in like user space is a ring level. There's 5 ring levels. System is a ring level, right? Virtual machines can run in user space, so they can run in system space, right? Depending on the type of hypervisor that you have. And so ring level intercepts all these privileged commands that should be accessing hardware. It intercepts those, lets them drop down to the kernel, down to ring level 0, execute where the kernel can simulate or present real hardware, and then the result goes back up. And that's how you protect. So ring level 0 is like the kernel talking to hardware, right? And so virtual machine wants to talk to hardware, but it can't because all the hardware is virtual. So we simulate it going down to ring level 0, run the command, back up to the virtual machine. So Dmessage, it examines and controls the kernel ring level. The ring buffer is a circular buffer where data starts at the top of the buffer and it just keeps writing over and over. So when we run this stuff like Dmessage head, and I'm just looking at the first 3 lines, what I'm doing is I'm getting some information about my system. So the system starts with a boot, right? And we can see here the second line down is my kernel command line from grub, right? Because that's where it starts. So when I run the first couple lines of Dmessage, the first 3 lines, I can see how the system booted. I can look at those things. A lot of people, when they're like, oh my gosh, you know, I don't know how my system booted, let me go and do etc default grub and try to figure it out, or I'll go into you know, /boot /EFI /whatever and try to look at a big long file to figure out what that boot command line looked like. Dmessage head, the first 3 lines, that's how you booted. If we go further down, we want to look at CPU. We can just grep for, I want to make sure I get this right, -I CPU, and then -N3. And so we can see here the type of CPU that I have. Allowing 16 CPUs, 0 of them are hot pluggable CPUs. Wouldn't that be sweet? And that gives me some information about, you know, 55 pages, CPUs, stuff like that. Okay, so I get some information about my CPUs. If I wanted to bring up more information, I can just change that head parameter, and I can look at more information about the CPUs. So you can see that last one, physical CPU allocation, 0. It starts with the socket number, and then we have the cores 0, 0, 0, 1, 0, 2, all the way up to 15. So 16 cores in the CPU. And then IO scheduler. IO scheduler can come in really handy sometimes when you're talking about performance tuning. And so the 3 different IO schedulers that this kernel understands are the MP deadline scheduler, the Kyber scheduler, and the BFQ scheduler. I believe it's deadline that that what it does is whenever a command comes in, it just runs it, right? It doesn't really queue anything. But the BFQ, and I think that is, I know the FQ is fair queuing. It looks at the ring level that the command came in on, and it prioritizes things so that it gets a fair chance to run on CPU. Like things coming in from the system ring level get higher priority than things coming into the user level, right? So it tries to keep the kernel system stuff running. And I think that's right. I could be wrong, but I think that's right. There's different queuing things. And sometimes you can change the performance of a system just by changing the scheduler. And all it does is change how different programs, you know, that need CPU time, how they get queued to run on the CPU. So there used to be one called completely fair queuing, CFQ, and that would just line things up in whatever order they came Some of the, I think it's the deadline one, can actually get you really close to what we would call like software real-time performance because of the way that's queuing things up. So it makes the kernel more deterministic because it just cycles things through very cyclically. It doesn't pause or wait for idle time or anything else. So things to think about, read on the CPU schedulers. You can change the schedule pretty easily, and that can change the performance of your system as well.
Those installed out of the box.
Yeah. Yeah. Yep. LS CPU, this is how we look at the CPU that we have in our system. And one way that this comes in really handy is with virtualization. We want to look at the flags that are set, make sure that the virtualization flag is turned on or safe. Every CPU has a virtualization flag turns on nowadays. It doesn't matter. But if you were to go back 5 years, you would have to check your CPU to make sure that the virtualization instructions were turned on. If not, you had to go in your BIOS, turn them on. But these are all the different feature flags. Intel CPUs will appear a little bit different from AMD CPUs. The instruction set is the same, but the feature flags are different. And you can go through here. If we scroll up a little bit in the terminal, we can see some information here about the actual CPU. So it's little Indian, 48 bits physical, virtual. There's 16 CPUs. It's AMD, and on and on. Probably interesting to read that stuff someday. We can do an LS PCI and look at our PCI devices. So this will tell us everything that's hooked up to PCI, which right now should not be a lot of anything except for what's inside of the computer itself. But you can see here I can get some information about audio processors. I have HD audio. I also have Renoir audio processor and so on. I have an NVMe SSD controller, and all this is hooked up to the PCI Express. Here we can see the NVIDIA GPU that's in this system. A lot of information there. The numbers off to the side are sometimes used to troubleshoot PCI issues or PCI assignment issues. Usually more in the USB side of things than the PCI thing. You'll see those numbers come into play. And talk about USB. If we do LS USB, there's all the USB devices on the system. So I have an HD camera that's turned on top of my laptop. And so you can see that, you know, Chicone Electronics HP Wide Vision HD camera is turned on. So those are some ways that you can look at the hardware in your system, either hardware hooked up to the PCI bus or hardware hooked up to the USB bus.
If you had a USB drive mounted on your drive, would it show up here?
Yep.
Okay.
Yep, absolutely.
It won't show on the left device. This is the raw.
Yeah, it'll show the, yeah.
Everything that is on the USB bus will show up.
Right, only if it's mounted.
Yeah, so if you have like a SanDisk USB device, it'll say SanDisk USB storage device.
Mount has nothing to do with it.
Yep.
It's just this is
Okay,
the
I
device.
Yeah, so again, the device IDs, right? This is a device ID for that particular device. And then the bus is on the device number on that bus, you know, because it's USB, so it works on it's a serial bus, right? So that'll tell you which bus is on, which device ID it is on the bus. And then it also gives you some information about the device itself. So again, storage device would show up as manufacturer storage device, usually.
Tell you that there's a lot more data than that whole sum.
Yeah.
And you get this per device, right? So if you're playing with UW roles and all that to figure out how to map in a USB, this is like where you would go to find that.
I forgot how to do this part.
It's a D or S or something like that. S.
S?
Either S or lowercase d.
None of them are working. All right, there we go. That should be it. Okay, so that gives me a lot of information about the video device. So, in case you ever want to know about your video camera.
So every time you think that USBs are just another fancy
Yeah, there's
This is
color
fine,
format.
same.
Yeah, there's a little bit of information coming off of your camera. Yeah, just a teeny little bit. All right. DMI decode is also another great way of looking at device information. And this will actually give you more information about what's going on in the BIOS. So you have to run sudo for this one. And here is my DMI decode. I should have probably run this through less.
Someone is asking online whether your laptop is a Lenovo laptop.
No, my laptop is an HP Omen. All right. So, so here inside of my BIOS, I can go and I can see information about my BIOS. I can see what's supported, what's not supported. I can boot from a CD. I can have a selectable boot. Right, gives me a lot of BIOS characteristics and what it can and cannot support. Yeah. ACPI is supported, USB legacy is supported. I can have a smart battery, you know. So lots of cool information in here about the BIOS. It gives you system information. Remember you saying how all those UDO bolts are all the same? That system information, UUID, should be unique. And that's what the U stands for, like universally unique. Yeah. It only is universally unique if the manufacturer wants it to be. That's what I learned. Yeah. So a lot of information here about your system, right? And you know, including asset tags, right? So if you're running a system where you want to gather asset tags and maintain an inventory.
Yeah, so I work a lot in an enterprise environment, and we'll get a lot of people saying, hey, this node's failed, I need the serial so we can RMA it. And they're like, well, there's no label on it. And so like, we'll tell people just do DMI decode, get into it, and we'll find it there. And
Yeah.
usually they do, sometimes they don't, but that's usually our go-to, like just run DMI decode, you'll find it. So.
Yep. Good stuff. So yeah, a lot of information here. Look at here, they even have for the battery. I can see the date that the battery was manufactured. So pretty cool stuff. DMI decode, great way to look and see what your system actually does. All right, so let's get into tuning some of the stuff. This is where we get into the really nerdy stuff. Configuring kernel tunables. All right. So we saw earlier how, get out of that. Kernel proc.
This is what I was getting at earlier in the presentation. This is how I was just looking at some of these things.
Yeah.
Use cat/proc.
Yep. So the proc command line, same thing as what we saw before when we were running that other command. I can't remember. But we can get the boot parameters, right? How did we boot our system? We can look at that through Dmessage. We can look at it through proc command line. This is copied over every time the system boots. The command line is copied into proc. And we can begin looking at that. There's a lot of cool stuff in proc, like you have proc mem info. There we go. Where we can look at all of the information that we want to know about our system's memory, and there's a lot of it there. Mem total, mem free, mem available. Again, the biggest thing that we need is 20% or more of memory to be free. We can look at CPU info. And there's all the information about our CPU. And this will go, yeah, so this one's showing my 15 CPUs, all that good stuff. We can look at swaps, which should be 0. We don't want any swapping going on at all. I've already changed that. We can look at process IDs if we want to look at process IDs again, information about running processes. So there's a ton of information that you can get out of proc file system. It's a virtual file system. It changes every time you boot up. Okay. The next cool thing we're going to look at. Oh, and you can actually change these too. I'm not going to change it because it's my laptop. But if you had a virtual machine, feel free to change that stuff. See what happens. If you do cat proc sys, right, we can see that there's some extra stuff down in here. It's a directory, file system. What do we want to look at? Break time, 45. Syskernel, that's a lot. OS, no. Hold on, drop my speaker. I won't be able to hear anybody. All right, so I can look at the version of my kernel that's running. Sorry about that. I'm terrible at typing. We can look at stuff about the kernel. We can look at tunables about the network settings if we want. So let's look at proc sys net. And of course, there's going to be a lot of stuff in there. We can look at IPv4, and there's 128 things in here. Great. What's a good one to look at? Conf, all. And what's another good one to look at? Forwarding. Okay, so if I look at my IPv4 stack, conf, all, forwarding, that number 1 tells me that I have TCP forwarding turned on. So I can actually, what that means is I can actually use my box kind of as a router. So if I'm running virtual machines, I can route from my virtual networks out to the physical network and back if I wanted to. Ton of information in here. The documentation for all the kernel tunables is in this link. And again, we'll make sure that everybody has a copy of slides at the end of this. But one thing you don't want to do is change any of these settings without knowing what you're actually changing. So read the documentation, see what you're changing beforehand. You can change things like down at the bottom of the page, proc sys VM tunables, which change the virtual memory management of the kernel. That can really affect the way that the kernel runs, right? And the thing is that, as you can see when I was going through there are a huge number of tunable things that have to do with the kernel and different subsystems in Linux, all underneath that proc file system. So be very, very careful how you change those. There's also things like syscalls and things like that we can do to change things. And that's what we're going to get into next, the tools that we can use to change some of these kernel tunable things. We saw that they're all stored in proc, right? There's a bazillion of them there. But how we change them really relies on the tools that we have. So we looked at some of these earlier, the CAC proc file system, forwarding. There's a bunch of things in there that we can look at. If we wanted to change something really quick and show you how it works, I'm going to resize my window here a little bit so I can come down here and maybe scroll up a little bit so I can see what I'm doing. IPv4, ICMP, echo, ignore all. Okay, so we can see that that is set to 0. If I do ping -4, 1 ping to localhost, it responds. Everything is working the way it should. Now, if I change this and I say change that parameter to a 1, right? I better use the single quotes. I don't think it would matter, but do it the right way. Okay, and I tried running that ping again.
Can't do that.
What?
You can't sudo with bot.
Really?
It tries to protect and all this.
Okay, now if I try to ping -4-E1. Okay, look what happens when I change that ignore echo. It was off, right? It was set to 0. Now I turned it on, so I'm ignoring all the echo requests, all the ping requests, all the ICMP traffic. So I submitted one packet to, I tried to ping once to localhost. I was denied because I have set my network stack, I tuned my network stack to ignore any of those ping requests. Can this have some utility? Yeah, absolutely. If you don't want people finding out that your box is online, turn that off, because the first thing that people do is usually ping to see if something's alive. And this way, if they hit it with any kind of ICMP traffic to see if it's alive, it doesn't answer, and you're hidden a little bit. If I turn that back to 0, turn off the option to ignore ICMP requests, I can ping successfully again. So you can do that from a security standpoint to change the behavior of your system. All of the settings in proc are kind of like that. Know what you're changing before you change it. Like that one's fairly safe because you're not really breaking anything. You're just telling it to ignore a certain type of traffic.
You may change the microphone, but using that persistent.
Yes. A way of changing things, and I'm not going to do any examples on this page, is syscontrol. If you run syscontrol-A, okay, I will do an example.
So was making that change persistent? Would it survive a reboot, or would it?
No, it does not survive a reboot.
Proc is basically at the right link to your kernel. And your kernel is a little bit good. So it's not, but it's a great way of testing out your settings. But if you want to persist, it's sysctl and a few other tools of what you would need to
If
do.
you want to persist, you have to go to etc sys.
Or you can set it through syscontrol. Yeah.
Certain command
So, yeah, so that one that we just did, ICMP ignore or echo ignore all, is tunable through syscontrol. So you can actually tune that and make it ignore all the ICMP requests through syscontrol.
when your system boots, guess what it does? It reads all of that data and then changes the kernel based on that.
Yep. So let's do it again. Let's change this. So I'm going to get that set to 0. If I do a -W and write, try my ping. My ping isn't not working. And I will set this back to 0. Now my ping works. So it's the same setting, right? If you want to persist it, yes, you have to put it in a syscontrol.conf file. And you can just take this part of the line and put it in syscontrol.conf, @syscontrol.conf. Yeah. Yeah, what Peter's saying.
I'm used to going into the editing file.
Well, that still works.
Yeah.
Or you can just pipe it in or whatever you want to do. Like,
Yeah, I bet the slow one, you just buy into it, set it, save it.
Yep. And so this is how you would set it to be persistent. See, we were going to get to this. So you can do the equals 60. You can echo VM swappiness equals 10 @syscontrol.d VM swappiness. You always want to use like this type of format. It's preferred where you use the syscontrol.d directory, and then you name your files so that you know what you're changing.
you get a system up.
So syscontrol.d vmswappiness.conf, or you could say ICMP ignore all.conf, right? And then you know where the different settings are for the different tunables really easily.
The star.comment, that's for,
Oh, that's just to see what's all there.
yeah, that's fine. Everything within.
Okay, so that's the only one I have. And this is something that the system wrote out. So, and there's nothing in it. It's just a bunch of comments. And it's probably telling me how to, that I should create a new file with the same to put new settings there, to override, only specify the things that you want to change. And again, read the documentation, make sure you know what you're changing, right? Because you can really mess up a system with changing things. All right. Another thing that you can do is you can change mod info loop. Yeah, that's a lot of information. All right, so sysfs file system. It's a pseudo file system which provides an interface to kernel data structures. The files under sysfs provide information about devices, kernel module systems, and other kernel components. Commonly used, if I run that command, I get a bunch of fun information. Okay, so this is the command being run. I get a modules directory. What else I get? I get a signature, so this is the signing key. Obviously, to increase security of Linux kernel, we started signing all the modules. That's the signing key for all the modules in the kernel, or the other half of the key. So everything is in there.
Yes, you ever have a tainted kernel? It's because you've got non-signed stuff in there. That doesn't
Yep. You can take a look at things like lssys module, and there's a bunch of modules there. Look at sys devices, and you can see all the devices that you have. Okay, so again, this is a pseudo file system. It gets created while the system is booting up. As it's reading all your hardware and devices and stuff, loading the kernel modules that are set to be loaded, it creates this file system so that you can query the file system and look at those types of devices. I think this is kind of more of the same. Oh, this is if we want to modify something. So the thing that I'm changing here, it changes the maximum number of loop devices and partitions per loop device. So by default, you can have a large number of different max devices. 0 is like unlimited. But if I sit there and change this to the options of max loop, that means I can only just create 5 loop devices on my system. So sometimes people will take an ISO image and they want to change it. So they will do a mount-loop ISO image, and it just mounts the ISO image to a directory. Allows reading, writing, and manipulating of the ISO image. So this is whether you can change that. And then the last thing we're going to talk about, because we are beginning to get low on time, is the TuneD project, or Tuned. Some people call it Tuned. Some people call it TuneD. This is the Tune daemon. But you can call it whatever you want, as long as people know what you're saying. All right, so Tuned, or TuneD, helps system administrators optimize performance because it provides like different types of profiles for different workload types. So there's several things there. You can see it has a website, the tunedproject.org. And it also does dynamic tuning. So if you set TuneD up to be dynamic, it will constantly change system settings based on the workloads that your system is running. Does it do a good job of that? Yeah, it does okay. It does pretty decent.
I've seen some systems that is set up right only.
Yep. So let's see. I think Tuned might already be running on mine. Yeah. Yeah, I don't have it.
It's not there. Remember you said you reinstalled everything?
Yeah. Well, you know, originally we were supposed to do this presentation, I think, back in March.
Yeah, I remember.
Yeah.
All
All right.
So you had all this time to prepare.
Yeah. All right. So TuneD is running now. Grep dynamic group. Thanks. All right. So dynamic tuning equals 1. That's cool. And then update interval is the other thing I'm going to look for. Not update. Update interval is 10. So what this is doing, okay, is those 2 parameters I just checked. Fedora is one of the distros that enables dynamic tuning. The first parameter that we look for is the interval, well, the second parameter we looked at is the interval in which it's going to look at the system and try to retune the system to meet the workloads that the system is running. A value of 1 indicates that it's on, okay? And then the 10 just means every 10 seconds it's going to look at things and say, okay, do I need to change the way that the system is running to optimize it? It is pretty cool. Anything that you change in that file will take effect immediately, and you could damage your system if you don't know what you're doing, so read the man page. Other things that you can, or other profiles that it has some already made up. And those are accelerated performance, so it's the throughput performance based on tuning with disabled higher latency stop states. Balanced is just a good general use. It balances everything out so that everything kind of works the same. Desktop high performance computing. Intel SSP if you're using an Intel chip that has SST technology. Latency network throughput. So if you have a high network throughput application, you can just say TuneD, use this profile, and it'll change the system so that network throughput is optimized. Power save, virtual guest, virtual host, all kinds of different tuning profiles for different workloads. If you want a list of all those and you want to understand them more, just do tuned admin dash or tuned admin list, and you'll get a list of all those things I just had on the previous page. Yes. If you want to change a profile, you just do tuned ADM, tuned admin profile, and the name of the profile that you want. That's it. It's pretty easy to use. So if you want like high network throughput, tuned admin profile, network throughput, and it's done. You can also ask, based on the work that you're doing, tuned admin, what was it, recommend. And it will go through and it will tell you what it recommends you should use. Okay, so it recommends that I use, even though I'm running a desktop, it's recommended that I use the balanced profile.
What's the criteria for what it would recommend?
Good question. I think it looks at the type of workloads that you're actually running on your system. I still run some containers, some virtual machines. So over time, it's probably like, just balance it out, just make a good general purpose system. If I was using a lot of desktop apps, it would probably recommend it the desktop profile. But since I still run virtual machines, containers, things like that, it's probably like, this is enough varying workloads. I should just balance everything out and let it run. So if you want to turn tuned admin off, you can just use tuned admin off, and it will turn off. If I want to look at the active profile, I can ask it what the active profile is. And my current profile is active or balanced. And when you activate it, what's interesting is if you turn it off and then you turn it back on, it comes up saying, oops, let me get rid of my terminal screen. It comes up saying, you don't have a current profile active. So you actually have to activate a profile at that point.
So how much resources does it use to
Not very much, actually.
monitor and tune?
Yeah, not very much. It's really efficient. So, but I don't have any stats on exactly how many system resources it can use.
All
Yeah.
it basically does, all this directories that look at all clocking sets, it has some rules about what they need to be set at based on what it sees, and it just sets those values. It's not like it does a lot of compute or anything else. It just basically says, here's a profile that says, if I need to be prepared for performance, I have to treat these parameters match. So you prioritize network over something else. That's basically it, and often they will just do it once and do it a group, and that's it.
And if you're into the cockpit web interface, you can come in a cockpit like that. And look at a system performance profile right down here. And if you hover over it, it says, yeah, this is the recommended profile and you're using it. But if you click it, I don't think it does anything, which is fantastic. Oh, there it is. It was a little bit slow. So from here, I can change to any of the other profiles that are on there. So I don't have to remember how to spell them or anything. I don't have to type anything on my keyboard. I just point and click. This is regular Fedora. This is Fedora Workstation.
I have like a billion more profiles than you do.
You might have created some. I don't know.
I swear, I have not created a profile called Oracle, but it's listed.
All right. And that's how you select it in Cockpit. If you want it to tune your profile a little bit, these are all kept in CD user lib. TuneD. And here's all my profiles. Okay, so if I want to take a look at my balance profile, this is my balance profile.
So it's basically just stating what values to have. So
Yep.
It's very, very low.
And it makes these changes into the proc or sysfs file systems for you. So it's dangerous for us to do it right, but if we let our computers make those changes for us, it should be better. So those are the changes that it makes. Okay? So you can actually change some of these if you want, but it's best just to leave it the way it is. So
Could you create a profile and then like write a script to push it out? Like if you have a network of multiple nodes, could you script it out, write it, and send it out to multiple nodes so that you know all of them have the same profile?
yeah, absolutely.
Good old answer.
That'd be cool.
This is a power save profile. So we can see audio times out after 10. Radeon power save has, because it knows it has a Radeon graphics card in here. ALPM min power, VM laptop mode 5. So it has a bunch of other settings that weren't in the balance profile to provide extra power saving features, right? And so just think, without TuneD, we would have to go through and read all the documentation, figure out what settings actually apply to what we're trying to do, and then change them. But this gives us, like you were saying, a good starting point, right? Where we can sit there and take that and be like, I want to mix between like balance and power saving. I want save power in some ways, but balance performance others. You can merge those together, edit them, and then push them out. Yeah, absolutely.
You can come with if you do find that, hey, I can make something more optimal, maybe put it out to the community and share your experience that this is a more optimal setting.
Yep.
It would make sense to have like your head node have that, a certain profile, and then your let's say your login nodes, those would be a lot. Another type of profile, maybe not quite as power hungry as your potentially.
You need to have to talk how to put VI.
All right.
That's okay. Just use your slide.
All right. So performance counters, you can do the perf utility to do performance counters. Has a list of defined events that can take place. But perf, it can instrument CPU performance counters, trace points, K probes, U probes for dynamic tracing. What? Ooh, okay. So perf, cool utility. Check it out. So you can do things like here on this screen. What I do is I use perf to measure how fast I can actually create a bunch of zeros and send them to nowhere. If those zeros are 2048 bytes in size, and there's a bunch of them. And so the perf utility, when I bring it up, it'll actually tell me like how fast the task ran, how many context switches there were, how many CPU migrations, like how many times did it move from one CPU to another CPU to finish this the system, how many branches, missed branches, seconds of time elapsed. This command would run for 3.5 seconds if I were to run it live. How much time is spent by the system and how much time is spent by user. So it gives you it breaks everything down for you, gives you more information about your system. You can look at specific events as well. So cycles, instructions, cache references are all done by perfstat-e, and that'll give you performance counters for all that. You can record events. So if you want to record things, put them into a record, or just push them out to standard input-output, which is the bottom example here. you can do either one of those. And again, running the dd command, it shows you actual symbols and stuff like that that were called in the kernel to run that command. So this is where you really start getting into the nerdiness of performance tuning. And then the last thing is eBPF. This is kind of a new thing, just came out in the 4.x kernel tree. I think all the major distributions are including it now, but it's the extended Berkeley packet, and I forgot what the F stands for, so it doesn't matter. But cool website here, they have a nice little B logo. And what it allows you to do is actually create points where you can come in and you can measure information by like injecting a monitor into different points of your system and gathering information from those different areas. And again, it covers pretty much everything. Performance Copilot covered 2,400 different metrics. This is right there with Performance Copilot with how much it actually covers. So it does a lot of really cool stuff. So CD Share BTC tools, I don't know why I did that one. Exec Snoop. So Exec Snoop tool traces new processes. For example, Xsnoop traces the exec CVE system call and shows details of the arguments and return values. So if I run a command with exec snoop, it will actually show me all the other things that those commands do. So it'll allow me to trace the whole command as it runs all the way through the system. So kind of cool. OpenSnoop is a tool that traces the open system calls. Okay, if we go back to this, these are all of the different system calls that it can look at. So exec snoop, open snoop, and then another one that comes with it is basic input output latency or bio latency. And that traces block IO or disk IO and records the distribution of IO latency and time. So as your, let's try this one actually. And I don't have it installed for some reason. Okay, so we'll ignore for now, but go through the slide deck later on, see how it works. It actually shows you how well your block IO was working over a subset of time or over a period of time. And it doesn't end until you hit Control C. Otherwise, it just keeps tracking and counting the size of how long it took to do actual operations. So you can see this distribution, like, hey, my disk is usually pretty fast around this time. Get host latency. That allows you to do some testing of systems. You can see here my highest latency was going to a system I have in my basement called Udo4. Udo2 is pretty quick, but going out to regular websites out there, Google and gstatic.com was also a little bit slow, but kind of cool. And it was using different commands too, so it showed me how long it took to get into those systems using different commands, whether it was ping or SSH. And that is it. So I'm glad we got through it. We're only a couple minutes late. Yay, performance tuning. And we'll make sure that everybody gets those slides. The stuff at the end with the eBPF, it's new. It's actually kind of cool the way that you can actually run different commands to tap into different parts of your system and gather stats kind of in real time, including how long it takes to run SSH commands, ping commands, or any other way that your system connects to other hosts. So.
That would be a good way, I think, maybe I'm wrong, but if you have a process that's running slow, you can pinpoint exactly at what point
Yep.
it's getting bogged down. You can say, oh, it's
You don't have to guess anymore.
Yep.
See.
But the biggest thing with performance tuning is knowing where to look to see how your system is actually doing. Some people will sit there and say, oh, my system's running low because, you know, I did meminfo and I see that I have like a 128 under swap. It should be 0, but it's at 128, right? 128 bits or bytes in swap. That might not be the biggest concern. How is the CPU working? How's your disk IO, right? That may be why you're swapping, and it may not just be memory contention issues or not enough memory, right? So that's why we spend so much time.
Reclaiming memory from the, doing garbage collection.
Yep. Yeah, Yeah, so it's worth knowing where to look and how to examine your system to see what's going on under the covers, behind the scenes, and then that's when you really start tuning. And the easiest way to tune is that tuning daemon. You can adjust things on your own, but the tuning daemon is much better. Yep.
We have a whole discussion based around, why something might be running slow versus what's actually, going on.
Yep.
If you're running a 10-year-old machine, but you're trying to run the most up-to-date software, you're probably not going to be able to find much to make it run faster and get, better hardware. But
Yep.
sometimes,
And that should have my.
Years ago, one of my wife's coworkers, said, "Oh, I'm just going to go and get a new machine. My machine's, so slow." And I asked her, "Describe it. She's running is newer than what I got at home at that time because I had a really old computer." I said, "Let me have it. Let me take a look at it." It had like several viruses on it. It was so. So once I got the viruses off, just immediately when I was typing, it was like I could see my key presses echoing, on the command line. It's like, okay, yeah, there's something really wrong here, but
Yeah.